Hi, I'm Patrick Fries. I'm a soil health scientist here at Ward Lab, focusing on everything from soil health testing, method development, carbon chemistry, and just general soil testing and customer support. Today, I'd like to talk to you a little bit about carbon some more. I did a previous talk looking at carbon in the environment, different carbon dynamics, how they're tested and why they're important, and how it applies to everyone from homeowners to large industry folks looking at this. Today, what I'd like to talk to you a little bit more detail is active versus stable carbon. I get this question quite a lot. Again, what I said in my previous video was all carbon isn't created equal. This is very specific to active and stable carbon. Active carbon is typically what is very sensitive to management in the environment, especially in agriculture. It's really susceptible to changes from tillage, no-till, things like that. It's the most accessible carbon source for microbes. And so it's really representative of what they're going to be utilizing for energy and helping with nutrient turnover, cycling in your system, and things that the plants can access for nutrients. We have a few different names for this. Some people call it particulate organic matter, and some people call it POXY, permanganate oxidizable carbon. There's a few different tests for this active carbon fraction, and we do a few of those here. And this, again, is an important fraction, but really what people are more concerned about is stable carbon. This relates a lot to carbon sequestration, long-term storage, climate change, some of those buzzwords that you see in the news. What this stable fraction is a long-term carbon that's developed and facilitated, tucked away in the soil by microbes. It's called mineral-associated organic matter, and it is, again, facilitated by microbes. What I mentioned in the last talk is how this is actually determined, and we use a very fine mesh, almost like cloth. It's 53 micron or 0.053 millimeter size, so it's about the silt to clay fraction size. That's the mineral-associated organic matter. We sieve the soil, and everything that falls through is the MAOM, mineral-associated organic matter. Everything above that is the particulate organic matter. The particulate organic matter is mostly plant-derived. It's the larger sizes that the microbes actually use for food. It's the active carbon. And again, there's other ways to test that active carbon, but for this, it's probably one of the quicker ways to do it. Everything that falls through is the mineral-associated organic matter, and that's all developed by microbes. A lot of it is microbial, I guess what they call necromass or dead bodies. That's actually protected by minerals, which is why it's mineral-associated, and why it's long-term, more stable in the soil because it doesn't break down. It's very well protected. That has a shelf life of about, some people say 50 to 1,000 years. The particulate organic matter, the larger sizes, are about, say 10 to maybe 100 years, 50 years, because it's so actively attacked or accessed by microbes that they use for food. For carbon sequestration, my other video, I talked a little bit about how that's being tested, which is just a bulk density, standard bulk density core, and then you can do a carbon test of that core. And the bulk density test is just the mass of the soil in your core over the volume of that core on a dry basis. You just take a sample of that and then you test it for carbon. You can do total carbon or organic carbon, but some people will actually take that soil and they'll run it through the mesh, and they can say, okay, of that soil that I have in that core, I can see how much of that's actually stable, is being sequestered, quote unquote, or is actually active. And that relates a lot, again, to management strategies. Or if you don't want that fine a detail, you can just take a carbon analysis of that core and you can get your carbon bulk density. But a lot of industries are looking at the stability of that carbon, and that is another finer detail that they can get for some of their, carbon credits. So that's some of the other tests that we do in terms of carbon analysis, in case you're curious. You can always call up here and ask us more questions about carbon testing. I'm always around, and we have other soil scientists, Dr. Ward, both Dr. Wards, Nick and Ray, and then staff agronomists who can always answer a lot of your questions. So thank you.